Way back to our seats, and we're going to get started with the second session. And following the second session, then we'll have our lunch break, which is a little bit longer of a break. All right, if we make our way to our seats. And again, if you want to pre-register for the upcoming seminar in October, there's an opportunity to do that at the back table. There's also a poster there that includes a little bit of information on that. You can also do that today online, get on and register for the next event. Encourage you to do that as well. These sessions are being live streamed, and also they'll be archived on our church website, so you can go back and watch them again and again. If perhaps you might have missed a few points going along in your notebook, you'll be able to go back along and just pause it and track through and pick up anything that you might have missed, or to share that information with other individuals, family members, that kind of thing. Some great information that we're getting here today, being educated, better able to defend the gospel, which is what it is all about. All right? So at this time, I'm going to turn it back over to Brian.
All right. Well, thank you, Pastor. How did you guys like the first session? Did you like that? All right, good. Yeah, like I said, I got that video from my cousin, and just that simple little, sending me a copy of this video called The Age of the Earth just changed my life. That connected the dots. It was Ken Hovind's The Age of the Earth. You can probably even still see it on YouTube. But he was really good at connecting the dots, and I started putting this stuff together. And then I stumbled across this book called In the Beginning. And again, for those who weren't at the session, I've got Solidify Your Faith YouTube channel, got a Give, Send, Go if you guys are watching online and you liked it. A lot of my videos show up on YouTube, a lot of creation stuff. And again, this is a thank you for any amount. And this was a picture of that state college down in Florida. It was so exciting, and that was just how God worked that out is a story amongst itself. How the security introduced me to the president of the college, and she's talking about, this is the free speech zone, and I said, well, I can speak freely here, but, there's free speech here, but how about inside the classrooms? And she goes, oh, yeah, I can speak freely there. I can share the gospel. I said, can you do it in class? Oh, no. And I said, well, could I get to speak inside? And she said, well, if a student organization invites you, you can. And I said, well, can you introduce me to their advisor? And she did. And this was the result of it. I had 5 or 6 classes and 5 or 6 professors and Chick-fil-A at the end. And I asked the advisor before I went up, do you want me to share the gospel? And he says, that's why we're doing this. And so I got to go in and say what they couldn't say. So again, if there's anybody watching online and you want a hired gun or whatever, if you want somebody to say what you want to say, but you don't want to take the heat, I'll come in and say it. I was invited to speak at the Rotary Club, and I had 20 minutes to tell them anything. And I told them about the hydroplate theory. It's a theory that just explains so much. It colors in the details, and it gives us another perspective of how the earth got here. See, if we have a perspective, we're going to see things through that perspective. Does anybody know what this is? So you guys obviously weren't in Mr. Wabake's senior math class in 1983. Okay? Yeah, I remember this from senior math. I don't know why. He drew it on the board, and he said, that's a bear climbing up the other side of a tree. And I add my art to it. And now whenever I look at that, what do I see? There's a bear climbing up the other side of the tree. So now when you look at the earth, and you're going to see how the earth is there, you're going to look at it through another perspective, hopefully. And I gave this talk at St. Cloud State and the University of Northwestern and other places, different churches. I called it Noah, What Caused the Flood? And it's one theory with only one assumption, and yet it explains 25 major features on Earth and in the solar system. Plus it makes predictions that are astoundingly accurate, like what's in a comet, or what's in why are there rounded boulders? And if you don't take anything else down, these are the best sources. Well, actually, they might even show up in your notes. RSR.org stands for realscienceradio.org. And that's what I listened to all the way down. I'm probably, I don't know, 20 hours from Minnesota or so, and so it took me a day or two to get here. I was in Baraboo that was probably 5 hours, and I did their revival. That was a lot of fun, and then went Thursday and Friday, I drove here, probably 7-hour days. And most of the time, sometimes I'll listen to the Bible, sometimes I'll try and practice my talks, but a lot of the times, I'm just listening to rsr.org. And there's a DVD. I used to buy the CDs and just plug them in. And I don't know if they're making them anymore, so I downloaded them. I got it on a flash drive. And I can that's how I learn. I've got a rolling university, and I'm listening to the expert creationists, and you could have astronauts or biologists or geneticists or geologists. He's just great. rsr.org. And then if you want to see this book, and this book used to be $35. It's out of print now. Now it's over $100. That's a sign of a good book when a value goes up once they stop printing it. And they're coming out, this is the 8th edition. They're coming out with the 9th edition, hopefully this fall. And I'm going to be doing a hydroplate theory. Let's see, the pieces open. If you go on my table there, I'm going to be emceeing a hydroplate conference in the fall. I think it was September 20-something. So grab one of those forms. It's going to be live streamed, and you're going to have sharp guys explaining almost every area of this theory. And so there's also a book in the back, 20 Reasons to Question Plate Tectonics. And this, again, these are just available for a donation of any amount. Yeah, but the plate tectonics is kind of like evolution. You can't question it. This is the only way you can think about the earth. And there's a lot of problems with this. So I encourage people to grab one of these for sure. And just get equipped. And it's just very, it's got nice pictures, nice graphs. And then you can listen to, they actually talked about this on rsr.org. Just go into rsr.org and type in 20 reasons or 20 questions for plate tectonics, and you'll get to listen to them. They had 2 shows going through it. So you don't have to read if you don't want, you can listen to it, but it's nice to see the pictures, and it's nice to support the people that are doing the work, that are standing up to the evolutionists. rsr.org/HPT. That's where you're going to get one page that has everything, links to everything. This is the people that write about it. Here's some videos that you can look at it. This is what the critics say about it. This is how we answer the critics about it. And this is why you haven't heard about it. Has anybody ever heard of the hydroplate theory? Raise your hand. 1, 2. Okay, so maybe, I don't know, a very small percentage. Okay, yeah, because the creationist models, the creationists, the big ones, don't talk about it until recently. ICR, the president, Dr. Randy Galuza, he just a super, super high integrity guy, smart. He's got an engineering degree, he's got a doctor's degree, he's got a PhD from Harvard, I believe, from community health. Just a sharp guy. Says very powerful things very gently. I don't know how he does it, but he's like a dog on a bone. He's very firm, but he's very gentle in how he does that. And I heard him speak last couple of years ago, and I asked him about the hydroplate. I didn't do it publicly. I talked to him later. I said, I didn't want to put you on the spot publicly, but I talked to him about it. He says, thanks for not putting me on the spot. But what he did is he invited some of the hydroplate experts to present to ICR and down in Dallas. So now he's like, I don't want to know what people say about the hydroplate. I want to know about what the experts say about the hydroplate. And he was able to present, and they allowed it, he opened the door. And so that was a huge, huge moment. And before that, a few years ago, CRS, Creation Research Quarterly, they actually gave a write-up of the flood models, and they included the hydroplate. And this thing came out in the 70s. And so there's been decades of people ignoring it, so that dam of censorship is starting to break. And it bothers me because we could have so much scientific clout right now if we would have been banging this drum instead of catastrophic plate tectonics. Because every few years, at least once or twice a decade, he'll make some astounding prediction. Or he makes the predictions. He's got 50 predictions, and every decade or so, they'll get proven right. And if you want to see it visually, you go into YouTube and Brian Nickel, Bryan, Nickel. Excellent. He's given me his slides that I can use. A lot of what you see, he developed them. And his Grand Canyon talk, I've seen a lot of Grand Canyon talks, but his by far is the best. And then also I've got my channel there, Solidify Your Faith. And if you want to see the 9th edition, you go into hpt.rsr.org. And so you can see the 9th edition. That should be coming out this fall. And we're having our own hydroplate conference online. You guys can be there if you want to. And so this theory answers a lot of questions. But if we don't know what the questions are, it won't make sense. It doesn't matter. So let's go through some of the questions. How do marine fossils get 5 miles above sea level? Mount Everest. And what causes a mountain to rise? What's the mechanism, energy, and force? We'll get to this. Walt Brown, he's an engineer. He thinks about forces and mechanisms and energy, and how does this all fit on the earth? And we'll get to that. Okay, what formed the Mariana Trench? It's the deepest part of the earth. It's 6.86 miles below sea level, key in the Pacific Ocean. That's key. And most of the trenches are in the Pacific Ocean. Why is that? And why is the Pacific so much different than the other oceans? And why is the Pacific, and why does it have 40,000 volcanoes at the bottom? They call them seamounts. And how did the mid-oceanic ridge form? What you'll see here, you don't see many maps with the ocean, what's on the bottom of the ocean. And I'll have this back out there by the table or somewhere, where you can see this ridge. Walt Brown thinks it started up here in Alaska. This ridge goes all the way around like a seam on the baseball and comes back to itself. It'd be the 8th wonder of the world if it wasn't covered in water. It's 40-some thousand miles long. It could be up to 800 miles wide, and it's made by stretching it in 2 directions. How in the world do you do that? Okay, that's a question. And then why? Okay, that's the mid-oceanic ridge right there. It goes all the way around the ocean, right at the bottom. And why are the mountain ranges parallel to the mid-oceanic ridge, at least the mid-Atlantic ridge? Why is that? They're all pretty much parallel. And if you notice up there on the west coast, where the Rockies are twice as wide as the Andes. And I'm thinking it's because we'll get to that. And how did the 90 East Ridge form? That's a vertical ridge that points straight north. How does that happen? And and they're stretched in 2 directions. See, notice if they come together, they're going to crumble. But if rocks pulled apart, it's going to crack in a straight line. The pressure's released, and then that's the way it is. And you got vertical and horizontal cracks, so it's being stretched in two positions and 2 forces. How do plateaus form? Why do major mountain ranges have plateaus right next to them? What is the force? What is the mechanism? And this guy says, what mechanism would cause a large volume of low-standing continent to rise rapidly a mile in the air? It's a double-sided mystery, too, and they go on to explain that. And then what caused the inland seas to form? Like the Mediterranean and the Gulf of Mexico, and I'm thinking maybe even Lake Superior. How does Lake Superior form? That's 600 feet deeper than the ocean, than sea level. How does that happen? And I'm thinking that's my question. Where did all the limestone come from? Because when limestone forms, it releases a particle of carbon dioxide. And there's 60,000 times more limestone than there is carbon dioxide in the atmosphere. So how does that form? And where did all the sediment come from? And if the sediment doesn't have limestone or carbon, that's in limestone, if there's no carbon in it, it's 65 parts granite, 35 parts basalt in rock, all right? So where did that come from? And what's the cementing agent? How did that get so evenly mixed and cause it to turn into rock? And what lays down layers of sedimentary rock all over the continent? And we looked at this last hour. It's all over the place, all over the world. How would that happen? How do canyons form under the ocean? These are submarine canyons. Most of the major river sources, they've got canyons in the continental ledge or in the continental shelf. How does a little river cut a canyon 18 miles wide, the Grand Canyon? What's 18 miles from here? There's probably the neighboring town 18 miles away. How does a river cut a canyon that wide? And where did all the limestone come from? How does this funnel form? Down by Grand Canyon. If we get time, we'll jump into this. But there's a big funnel down there in barbed canyons. And then Grand Canyon, where'd all the dirt go? 800 cubic miles got pushed out of there. Where did it go? And a guy used to give tours down there, and he always used to say, you know what, he'd look at the canyon, and he said, I dug that. And a little girl said, well, where did you put the dirt? And it haunted him the rest of his life. It's like, yeah, where did all that dirt go? And also the mesas, buttes, and spires. This is one of my most popular talks. I think it's my second most viewed video. It's only like a minute or two long. You know, how did mesas, buttes, and spires form? How about petrified trees? How did they form? And lineaments. These are straight features on the earth. What would cause straight features on the earth? How does a canyon form under 2 kilometers of ice in Greenland? And it was cut by a river. It's sharp. It's not rounded like a glacier. And how do you get lakes under 2 miles of ice down in Antarctica? And Russia's drilling down there, and the environment, and they think that down there it's got this isolated test, a test. It's been isolated from everything in the world. They think that everything's evolved differently there. And Bob Enyart says, no, you're going to find stuff like a normal lake. And Russia's digging down there, and the environmentalists are freaking out about it. It's like, you're gonna wreck everything. And the Russians say, well, we appreciate your input, and they kept on drilling. And they finally reached it, and they found stuff that was, Bob Enyart was right. It didn't evolve any differently. So how do you get lakes, liquid water down there when it's, the average summer temp is below freezing? Okay, and also this textbook, 8th grader science in St. Cloud, South Pole is mostly covered by ice, but fossils show that crocodiles, dinosaurs, and palm trees once lived there. Palm trees. I mean, if it was warmer, maybe the animals could live there, but that's dark, 4 months of the year. How are you going to get palm trees there? And then on the North Pole, you get Axel Island and Altsberg Island, you got snakes, tortoises, alligators, badgers, and shrews. How are they going to live in permafrost? That doesn't make any sense. And then they also find frozen mammoths in permafrost. What froze the mammoths? And this one here, it's in the St. Petersburg Museum, it froze standing up. How do you freeze an animal standing up? And it still had identifiable food in its stomach. Any hunters here? What do you do first thing you do when you shoot the deer? Gut it. You got to get the heat out of there, right? Can you imagine how much heat is in an elephant's stomach? I mean, that would just it had to be flash frozen. How are you going to flash freeze a mammoth? And how did it get so fast, so cold during the summer? Because they could tell it was summer based on what was in his stomach. And then why didn't it thaw out? Okay, yeah, you froze it, but why won't it thaw out? Because mammoths are not Arctic animals. They need too much food, they need too much water, they're not woolly, they're hairy. And then that brings us to the Ice Age. What caused the Ice Age? And I saw a map of the Ice Age. It's kind of hard to find. When I found this one, I was jumping up and down. And you can ask my wife, but how come there wasn't a glacier in parts of Alaska? Isn't that odd? You got glaciers all the way close to here, in Minnesota for sure, and yet parts of Alaska where there's permafrost, they have no glacier. And the same thing in Siberia. Permafrost today, but no glacier in the Ice Age? That doesn't make sense. And then they find redwoods grown in permafrost north of the Arctic Circle, and they're huge. They say 45 million years, but again, that's where a baloney detector goes off. And some of these had a diameter of 10 feet, 10-foot diameter tree. They figured it was 90 to 130 feet tall. How's that going to grow where it's dark 4 months a year? It doesn't make sense. And then they've got this ratio of deuterium. Hydrogen is a proton and an electron. Deuterium is a proton, an electron, and a neutron. Where did that come from? And how come the comets have twice as much as the ocean? Because their theory says the comets brought the ocean to us. You don't buy that, but then why isn't the deuterium ratio the same? And then how do you fuse past iron? How does that happen? And then the star element. The problem is astrophysics aren't quite sure how stars did that. They aren't sure. So what do we find in comets? Why does comets have stuff from the Earth? We find water, salt, silicates, crystalline silicates, limestone, clay, cubonite, olivine, iron, nickel, amino acids. That's used for life. Organics, bacteria, cellulose, that's wood. How does that get in a comet? I mean, some of that stuff had to be formed, especially this cubonite. I showed you this last hour. Cubonite that forms only in the presence of scalding hot water. According to all standard explanations for comets, it's impossible to form liquid water inside a comet. Liquid water cannot reach extremely hot temperatures in comet's low-pressure environment. So it's not going to get hot. It's just going to go from liquid to steam because there's no pressure. How do asteroids get moons? How do peanut-shaped asteroids form? We showed you that, but now we're going to answer that. And it's a major unsolved mystery how two objects, each the size of skyscrapers, could collide without blowing each other to smithereens. Especially puzzling in a region of the solar system where gravitational forces would normally involve collisions at speeds of up to 4,500 miles an hour. And this is from Aviation Week and Space Technology, March 20, 2006. How? How do you get them to come together gradually? It's very puzzling. A lot of these are some of the unsolved mysteries of science, what we're talking about. And then they found rounded boulders in Comet 67P. Rounded boulders again. How do you get a rounded boulder in space? And then asteroid Florence has 2 moons. I mean, let alone 1. How do you get 2? And also this thing called chondrules. These are kind of like melted rocks. It's electrically charged. There's something, those circles in there, something happened, like an electrical charge or something. And they're in meteorites. How does that happen? So they say, oh, there must be lightning out in the universe or in the solar system. It's like, well, how does that form? Okay, and why is the far side of the moon so much different than the near side? It's 30 degrees colder than expected on the far side than on the near side. And if that was there for billions of years, it should all be the same. Okay, something happened not too long ago from there, in that perspective. Okay, why is the near side of the moon pounded and the far side peppered? See, we only see one side of the moon because they call it gravitational lock. So we only see one side of the moon, and our side is pounded, where there's a lot more lava flows and moonquakes, and the far side is peppered. And that's counterintuitive because the Earth would protect anything coming from the outside. So we'll answer that. And again, the far side, it's so much different. They don't have the lava flows. A lot more high density on the near side than the far side. And again, it's counterintuitive. It's, the Earth itself is going to take a lot of those hits. Then when you throw in the gravitational force of the Earth, man, it's going to be really hard to hit the near side. And yet it's pounded. And why is the Earth's oldest rock found on the moon? How did a rock from the Earth get there? Then how do canyons form and water erosion form on Mars? So there's a lot of unanswered questions. And then comets. If they're going around the sun, like in the same orbit as us, they call it prograde. And if it's going backwards, they call it retrograde. And if it's coming from the Oort cloud, it should be 50-50 mix, but it's not. The short-term comets, those that come by within under 100 years, 97% of them are going in the same. Okay, and then the medium-term period comets, they come by every 100 to 700 years. That's still a 70-30 mix, prograde. And then the really long-term periods that are over 700 years, now it's more random, more of a 50-50 mix. Why is that? Okay, and then also the iron. And then these are some of the great unanswered questions in physics. How were heavy elements from iron to uranium made? They don't know. Okay. All right, so we asked all those questions. And if there was one theory that could answer all those questions, tie them all together, would that theory be worthy of study? Who thinks that it would be? Yeah, that would be worthy of study, but it's not. But that's going to change. We're starting, the dams break, and it's going to flood, I think, because this is what colored in the details for me. Kent Hovind connected the dots. Walt Brown colored in the details. It's just phenomenal. And the simplest theory explaining the most details is probably correct. And this is a simple theory. It really is. And so on with Walt Brown. Okay, and now it's fill in the blank time. It's one assumption. But Walt Brown, he went to West Point, was an Army Ranger, paratrooper, got his PhD from MIT in mechanical engineering. He ran the Benet military lab where he had hundreds of scientists and dozens of PhDs. So he's in a circle of well-educated people, all right? And he's driving through South Dakota back in the 70s, and he hears on the radio that somebody found an ark. They say they found an ark on a mountain. He thought, what a crackpot, that's crazy. He's an evolutionist, right? And anybody ever drove through South Dakota? Not much there to do but count the wall drug signs, right? And so he starts to go over in his mind, if there was a ark on the mountain, he just, I'll humor it. Okay, if that happened, that means the whole world was covered with water. Okay, and if the whole world was covered with water, that's going to bury a lot of plants and animals and turn them into fossils. And he thought, wait a minute. If the fossils point to a flood, where's the evidence for evolution? And so he started to ask all his well-educated colleagues, what evidence do you have for evolution? And after 2 years of asking, he never got any evidence. And so then he became a creationist, and he dug into the Bible. And this is Walt on the left, Bob on the right. It's just my favorite. You know, those two, listen to those two on rsr.org. Just go rsr.org and Walt Brown Week. And he just explains it perfectly. It'll color in the details. And then you can watch the stuff on Brian Nichols' YouTube page. You know, his animations are just priceless. I'm more visual than reading, so I love watching these videos. And we had him speak at our Twin Cities Creation Science Association. And if there's anybody watching online and you have a regional creation club, Brian Nichols would be a really good one to Zoom. And that's the neat thing, a lot of technology. So this is the book, In the Beginning, and this is the whole theory. It's all-encompassing. And it starts with one assumption. And now let's fill in the blank. Half of the ocean was inside the earth. A layer of water roughly a mile thick under 60 miles of granite. And the water, I got a graph there. Water's the white part, and granite's the black part, and basalt's gray. And they're touching each other. So this is an illustration of what God made, I believe. There's a layer of granite 60 miles around. Just think of this as a big apple. Okay, the skin is 60 miles thick, made of granite. Then there's a layer of water, a layer of water going around about a mile thick, and underneath that is basalt. Okay, that's just the one assumption. That's it. And I went to St. Cloud State, I do that a lot, and I talked to a professor in the geology department, or the earth science, and I said, you don't have a theory for Grand Canyon that works. And she knows that. And I know that because my brother-in-law, he took some hydrology classes and geology classes there, and for a week they're trying to figure out how the Grand Canyon formed. And none of the theories worked. And then on Friday, the professor said, you know, there's one theory we haven't looked at. Anybody know what it is? Kid says, Noah's flood. And it got real quiet. And the professor said, you're right, but we can't talk about it. Even though their theory doesn't work, they couldn't talk about a theory that could work. And Grand Canyon was not formed right after the flood. It's too soft, it would have slumped in. It needed time to solidify. That's my opinion. But again, eat the meat, spit out the bones. You know, don't believe anything I say, but check out what I'm saying to see if it's true. Okay, so that's the one assumption. Okay, and then now we're going to throw in the laws of physics. Here's another one. The moon's gravity tugs on the Earth's crust, causing it to stretch and contract. Okay, so the moon's gravity is going to cause it. It makes high tides and low tides. It's going to do the same thing with the crust of the Earth. And as you stretch it and compress it, it's going to heat up. Kind of like if I had a wire and I went back and forth, it's going to get hot. Well, the crust is getting hot. That heat has to go somewhere. It goes into the water. The water gets hotter and hotter and hotter. It wants to boil, but it can't because there's no room to expand. And at 705 degrees and 3,200 psi, it becomes supercritical water, where it's not really water and it's not really steam, but whatever it is, it dissolves things like crazy. So now it's starting to dissolve the crust, the granite above and the basalt below, and it's starting to dissolve it. It's going to mix these chemicals together and materials together to make limestone and chalk and quartz and salt and all these, and some of these are cementing agents, and it's starting to build up in the fountains of the great deep. And so the crust is getting weaker and weaker, and it's getting hotter and hotter, and eventually there's so much pressure, and I think they said it was 372,000 psi. Can you imagine all that pressure underneath that crust? And it cracks. And that crack is going to go in two directions all the way around the world. And the water is just going to erupt out of there from 372,000 psi to 14 psi. So it's just going to erupt with tremendous force, and the fountains are going to go up, and that's how it's going to rain for 40 days and 40 nights. It's the fountains of the great deep is what the Bible says for 40 days and 40 nights, and it just shoots up there. And people will say, well, if that happened, wouldn't that leave a mark on the earth? I said, yeah, it did. It's called the Mid-Oceanic Ridge. That's what happened. It goes all the way around. So at about 3 miles per second, it'll get around in 2 hours, or vice versa. And then it collapses, it connects to itself, and then it just keeps erupting out of there. And so now what happens is you've got a cliff 60 miles high with water gushing out of there with tremendous force. And granite can only handle so much pressure before it starts to crumble. That's why you never see a cliff more than 5 miles high on Earth, because granite will turn to putty and it'll collapse. And we got 60-mile cliffs. So these cliffs are crumbling into that supersonic water, and that's where the sediment that was in the Great Deeps is starting to get put out on top of the earth. And okay, there's the cliffs eroding, the sediment's going all over the top of the earth, and it's roughly a mile high on our continents, the sedimentary rock. And these, again, that's how you get a bunch of layers of rock all over the earth and all over the world. Okay, worldwide layers of sedimentary rock. And it's a strong argument for a worldwide flood. But evolutionists, they can't have a worldwide flood because they put their faith in the geologic column, and a worldwide flood would erase that. So they have to say, okay, Noah's flood was a local flood. And then they'll think, okay, instead of one big catastrophe, they think there's millions of catastrophes. So they're doing a lot of mental gymnastics. They don't have to believe the Bible, and there's reasons for that. Okay, and so it's cutting and cutting, and now the continent, those cliffs are getting farther apart because of all the erosion. Okay, eventually there's nothing pushing down on the mantle, and the mantle bulges. That's the Mid-Oceanic Ridge. It bulges, so it's getting stretched in 2 directions. It bulges, which causes the plates. See, before the continents, before the flood, the Earth's had the crust. It wasn't broken into plates like it is today. It was the crust. But then when the fountains of the Great Deep broke up, it cut those plates into pieces. Okay, the crust into pieces. And now those plates start to slide. So now you got North America and South America, they're sliding to the east, and sliding to the west. North America and South America sliding to the west, and Africa and Europe sliding to the east, and they keep going until they meet resistance. And then they buckle. The mountains rise up like a car. It hits resistance, it buckles, or a rug going into a wall, it's going to buckle. And that's what caused the mountain ranges to be parallel to the Mid-Atlantic Ridge. Walt Brown doesn't think the Atlantic Ocean was there. He thinks a lot of that eroded away and those things slid away. That's how you can get the pieces to fit. If you just put them a few hundred miles from that Mid-Oceanic Ridge, it fits perfectly. But if you try and have them touch each other, you have to shrink Africa and you get rid of South America. Okay, and so that forms the Mid-Oceanic Ridge, and right there, I think the Rockies slid over, North America slid over the ridge. That's why it's twice as wide as the Andes. And as it's sliding, there's going to be tremendous force. It's going to turn a lot of that granite into lava, and it's also going to form coal and oil deposits and metamorphic rocks, and it's going to make marble, which is actually limestone plus 1,600 degrees Fahrenheit plus pressure, and diamonds, which is carbon plus 1,600, or coal plus 1,600 degrees Fahrenheit plus pressure. And they've found carbon-14 in all of those. Carbon-14 is the creationist friend because it proves that stuff's not over millions of years old. Carbon dating is only up to like 50 to 100,000 years. If anything has carbon in it, it has to be less than 100,000 years. And they find it in diamonds, and they find it in coal. And it doesn't matter which layer of the geologic column they take the coal from. It's got the same amount of carbon. And then you get the folded mountains in British Columbia, and they're not cracked. It's just these layers are all squished together like an accordion. And if you want to do a scientific experiment at home, just take your finest piece of china and bend it. See how well it bends. See, this stuff bent, it didn't break. And then there's crushing too. This is Gunnison Canyon in Colorado. And for scale, those are 15-foot trees on top of that canyon. And so there was some tremendous pressure that squished this granite, tremendous pressure. And the thing that's going to melt the first is quartz, and that's what fills up those lines. And they're compression cracks, not tension cracks. And I don't know if anybody does any casting or molding industry, but it's really hard to get that through the small stuff, but that's what happened. And you get that same type of rock underneath the Grand Canyon, crushed together. And I have a rock here, and I think this is kind of what happened with this rock. To me, I think this is granite, and then there's melted stuff in between it. I'll have it on my table in the back. This is what I think happened when there was so much force. Okay, so then there's the Mid-Atlantic Ridge, and you zoom in on that, and you see it's stretched in two directions. Okay, so it's validating that theory. And then the plateaus. Mountains rise up, you got a big mass on a small base, and it starts to sink. Well, if something's going in, something's got to rise up. And that's the plateaus. And so what's the force that made the plateaus rise? It was hydraulics. You got a big liquid going down, and then it shoots up at break faults all the way up. That's how you get the plateaus to rise, and it's hydraulics. And then the other major mystery is how did you get it to grow down at the bottom? But then you're going to get lava going up between those cracks. Lava's going to go up. You're going to get some lava flows. It's going to be hard on top. So if water ever comes by, it's going to erode away. It can't erode away the hard stuff. So it's going to go around it. And you see something like Red Butte, which is down by the Grand Canyon. Okay, with me so far? Okay, so now you got the Mid-Oceanic Ridge is rising up. So similarly like the mountains, if something's rising up, something's got to sink in, or opposite of the mountains. And that's where the Pacific Ocean sunk in. That's why it's the ring of fire. It sunk in because the Mid-Oceanic Ridge came up. It sunk in. That's why you get all those volcanoes and that ring of fire in the Pacific Ocean. And that's why the trenches are there in the Pacific Ocean, the Mariana Trench. And there was even a continent that sunk down. Okay, and look at all those volcanoes there. Yeah, there was a lot of pressure there. And then even a continent, there's another continent found, the eighth continent called Zealandia. Sunken eighth continent reveals its buried secrets. And that's what Walt Brown predicted. He predicted they'd find some granite, some continental crust in the Pacific Ocean. And they did. And they found evidence of land-based fossils there. And that's what it looked like, Zealandia. New Zealand is like the mountain range of that continent. And it's about the size of India. Okay, so the continental shelves, how do you do that? The pressure is going to be greatest at the nozzle of those. Just think of those plates. They're going to bounce up and down, and they're going to erode more. So that's why you get the continental shelf. And then the continental slope is what got eroded away. And so how do you get these submarine canyons? Well, the world's covered with water. The Pacific Ocean sinks in. So now the water gushes off the continents to fill up the Pacific Ocean. And so then it's going to cut canyons in that continental shelf. And Walt Brown says that the continents were higher back then. They're sinking in. And then it causes the oceans to rise up, and that's going to bury those canyons under the ocean. So they were cut pretty much right after the flood. And you can see these canyons at the end of the Amazon, the Congo, the Hudson. And so you can see those cut there. So then you get these canyons cut. Well, how come that's under 2 kilometers of ice in Greenland? Well, then how do you get them lakes under 2 miles of ice? So the water gushes off, cuts the canyons. Any depression is going to have water in it. That's what happened in Antarctica. And talking about global warming, they found 91 new volcanoes beneath Antarctica's ice. You think that might melt some ice? So again, I do a talk on the climate change on my YouTube channel. You can check that out. But I encourage everybody to read Inconvenient Facts by Gregory Wrightstone and see what's exactly happening. Because basically carbon dioxide, which they're destroying our economy, they're modifying our economy to reduce carbon dioxide. And carbon dioxide is not a pollutant, it's plant food. If we had more carbon dioxide, we'd have more food and less droughts. And I encourage people to get another perspective. Just like creation, evolution, you need to see creation. Okay, and then with plate tectonics, you need to see the hydroplate. And also with climate change, you need to read Inconvenient Facts and see another part of it so you can get all the information and come to your own conclusion. And be very careful about who's funding the science. Inconvenientfacts.xyz, excellent source. You can see videos. Also co2science.org. You can see how much more food we'd have. Okay, and that brings us, okay, that was a side issue. I hope that was okay. But how do you get those canyons full of ice and those lakes covered with ice? That brings us to the Ice Age. And the evolutionists or the atheists, they got about 40 different theories on how the Ice Age began. And once it starts, it's going to keep reflecting the heat, so it should never stop. How do you stop an Ice Age? And and then how come you didn't have a glacier in Antarctica or in Alaska and in Siberia? Okay, so to get an Ice Age, it has to snow more than it melts year after year after year. So how are you going to get that much snow? Well, it had to be warmer oceans. You need warmer winters and cooler oceans to get it, or warmer winters and cooler summers to get an Ice Age. And so the warmer oceans had more precipitation coming down on the continents, which were higher, therefore cooler. And also there was a lot more volcanic activity, so the atmosphere is full of aerosols reflecting the sun's heat. And so you had more precipitation coming down as snow. The winters or the summers were cooler, so it's not melting. So you got 400 or 500 years of it snowing more than it melts, and you got the glaciers everywhere except for parts of Alaska and parts of Siberia. Well, why didn't it form there? Because it had the moderating effect from the ocean. It came down as rain. It was warmer there. It might have been lower there too, so it was warmer. In parts of Siberia, it came down as rain instead of snow. And they had this volcano in April of 1850. They had the year without summer. They had snowstorms came in June. This is in New England. And lakes froze, had ice formed in lakes in July and August. So that's just one volcano with the sediment, aerosols up in the dust up in the atmosphere. Can you imagine what hundreds or thousands of volcanoes would be doing to our atmosphere? And that's when I think the Neanderthals lived, because they had rickets, and that's a vitamin D deficiency. Or they had vitamins, they weren't getting all the vitamins they needed, so they had diseases. And we'll cover that tomorrow a little bit. And then how do you freeze a mammoth how do you freeze that in permafrost? Well, the thing to realize about mammoths they're not, oh my. We'll fill in the blanks later, okay? Mammoths are not Arctic animals. They have hair, they eat 300 pounds of food a day, they drink 30 to 60 gallons of water a day. They can't survive in the Arctic. And their nose, your nose gets cold in the winter. Can you imagine if that was 6 feet long? They're just not, they're a temperate animal. They live where there's lots of food and lots of water. And so how do you get them to freeze, especially standing up? Well, that's because that's cold hail. Some of that stuff was erupting out of the great deep with such force it went up and it cleared our atmosphere and got super cold up in space. Then gravity grabbed a hold of it and pulled it back down as muddy hail. And what's frozen carbon dioxide? That'd be dry ice. So you got frozen water and dry ice and sediment coming down as muddy hail, and it buries those mammoths, flash freezes them, buries them with I don't know how much mud, but then the flood came over, it never thawed it out, and then over time the erosion is starting to make us so that we can find them. Okay, and it's just froze them right down there, and Walt Brown says, we'll never find oil underneath mammoths. We'll never find fossils underneath them. And so that's what he says. And again, there's some other data coming out that could, dispute this, and that's okay. Let's get all the evidence on the table. I need to study that more, but just understand this, there could be chinks in this armor, but it sure does explain a lot. Okay, and so that's the cold hail. And yeah. Okay, cold hail. And so how come it didn't thaw out? Okay, well, that brings us to the big roll. You take the mountains, the northern mountains and the southern mountains, they pretty much cancel out, except for the Himalayas. There's nothing in the south to cancel out the Himalayas. So if you had a big mass, that's what that orange is, and you start spinning it, that mass is going to try to get to the equator. So it's taking what's on top and bringing it to the side, therefore taking stuff on the side and bringing it to the top. And so the mammoths, they were in the temperate area, which was on the side, and then the whole world rolled. Do you see how much it rolled? And so then Mammothville, where they're fat and sassy and well-fed and watered, moves up to Mammoth Chill, where they never thawed out. And okay, so if that happened, would that leave a mark? Well, I think it did. See the equator, and that would bring, all this stuff, these temperate animals from the side up to Antarctica, and it would also bring tropical palm tree down to the bottom to, that one would be Antarctica. The other one would have been up to the Arctic. And we need to realize that the equator, the world's not round perfectly. There's a bulge at the equator. Okay, so when it was shifting over that bulge, it cracked the Earth. And that crack is 3,000 miles long. That's the 90 East Ridge, pointing directly at the Himalayas. I mean, there's a lot of, it's just directly straight. And so that's how Walt Brown thinks it got there, because things aren't normally straight in nature. Okay, and so then what caused the inland seas? Okay, and the lineaments. How do you get straight features on the Earth? And how do you fuse past iron? Those are all you have to watch to get the real information. Go into Brian Nichols, The Origin of Earth's Radioactivity. He does a really good job at that. Okay. All right, so granite, they find, during earthquakes, they find lightning linked to rift zones. Lightning, that's odd, isn't it? Lightning in the ground. Well, why would that happen? And this is nature, earthquake lights linked to rift zones. This is from nature. Also, electrification phenomena in rocks. And Nova says, what causes eerie earthquake lights? And why do lights sometimes appear during an earthquake? Bizarre Earth, this is National Geographic, the other one was Smithsonian. Bizarre earthquake lights, finally explained. Okay, mysterious flashing earthquake lights, maybe explained. And what we need to understand is granite is made of feldspar, mica, and hornblende, and quartz. Okay, quartz is piezoelectric, so if you stretch it or compress it, it's going to make a spark. Okay, could you imagine the whole continent getting stretched on top, that's tension, and getting compressed on the bottom, causing sparks? That's what I think lights your electric grills, or not your gas grills. There's something that hits the quartz and then it makes a spark. And they call this fluttering. And it's going to flutter back and forth based on the water pressure, because if the water's shooting out and it releases the pressure, then the plate slams down on it and shuts it. And then it gets more pressure and then it shoots up again. So it's going to slam down, and they call that fluttering, kind of like a flag. And that's going to cause straight things. That's going to cause the lineaments on the surface of the Earth, which are straight. And then we went through the electronic stuff. And then it's going to slam down. The granite's going to slam down with such tremendous force, and they have this thing called Z-pinch. And the fluttering going up, it's going to slam down. It's going to do that electrical things into the side of the rock, deforming it, making the chondrules. Then they get shot to the side. It slams down on them, builds up the pressure. When enough pressure gets built up, it shoots up into the atmosphere. Except at this time, not only did it go through the atmosphere, breaks the atmosphere, it breaks our gravitational pull and just keeps on going. And that's how you get these chondrules out in space. Okay? All right, so and then also there's going to be nuclear energy in there. And it's kind of like lightning. This is Z-pinching, where they get this material going so fast and they slam together and they make these heavier elements. And that could be happening with that granite and getting past iron. Z-pinch, so they'll hit something with super hot dot, going really fast, and it makes all these elements, 94 elements and super heavy elements, and they're radioactive, and they go up there, and then they stabilize into that valley of decomposing, that that valley of stability. So they have this thing called plasma. In lightning, there's kind of like plasma. It's like the electrons get sheared off from the particles, and then there's the expansion, and the boom, the air slams together. That's the thunder. Well, that's not going to happen in granite, Granite can't expand like that, but it's still going to come back with tremendous pressure, and it's going to push those things and make different elements. Boom. So that's how we get radioactive material. And then he thinks that uranium and the radioactive materials were formed during the flood, because God said after the day 6, everything was very good. Is it very good to have radioactive elements in the earth that could cause birth defects? And why do we always find the radioactive material by granite? It's never under the ocean. Why is that? And then again, it goes up, it's really radioactive, and then it breaks down into that stability. And then it's going to make it's going to make certain parts of the continents weak with all that radioactivity, and it's going to shoot out. That's how you get the inland seas. Boom, 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 it just shoots out. And they find a lot of salt at the bottom of that Mediterranean Sea. And it's going to cause free neutrons, and those neutrons could join up with hydrogen to make deuterium and go up into those comets. And what else gets shot up during this process? You're going to get water and salts and silicates and crystalline silicates and limestone and clay and cubonite and olivine. That's what Walt Brown predicted. He said, when we find we're going to find olivine in the comets, when we find out what's in a comet, and iron and nickel and organics, and that's what they found. And I encourage you to listen to Kevin Lee's. Go into rsr.org and type in Kevin Lee, because there was the Dr. Brownlee. He was in charge of the Stardust mission. They were going to go up there, they were going to get some pieces of that comet, and they were going to come back. Just an amazing engineering feat when you think of it. And Kevin Lee said, you're going to find stuff from Earth there. And he gave him a copy or a link to the copy of this book and asked him to read it. And it's very interesting to see. And then they found out what was in the comet, and they wouldn't release it, because they were, Kevin Lee saying, you're going to find stuff from the Earth. And they're saying, no, comets come from the Oort cloud. It's way cold out there. We aren't going to find anything from the Earth. And they found out what was in it. They wouldn't release it. You can listen to this on our TCCSA, Twin Cities Creation Science. We had him speak. And it was amazing. They didn't release it. They wouldn't release it. And then when they finally released what they found, they said it came from the inner solar system. They didn't want to say it came from Earth, but they said it came from the inner solar system. So some of those comets, some of that stuff was going at the same direction as the Earth. That's why most of the short-term comets are going in the same direction. Like if you're on a train going 100 miles an hour and you throw something out 50 miles an hour, pretty much any way you throw it, it's going to keep going in the same direction. That's why the short-term comets are pretty much all going the same direction as the Earth. And then if you're going 100 miles an hour and you throw something out at 150 miles an hour, well, now you're going to have more of a, it's going to have more of them going that way. But then, so that's why we have a 70-30 mix. And then if you're going down that train and you shoot something out 500 miles an hour, so tremendous force, now it's more like the 50-50 mix. And these rocks, when they get out there, the big rocks are going to have gravity, and they're going to start collecting the other ones in their sphere of influence. And some of these big rocks, and they're going to make other asteroids, and they're going to be going the same direction. They're going to make these comet-shaped ones. See, like if the evolutionists, they think everything's going really fast, and they're going to come together, they're going to break apart, like playing pool. The only way you get a peanut-shaped one is if they're going in the same direction, at pretty close to the same speed, and it'll come together gently. That's how we get the peanut-shaped ones. And then the rounded boulders in Comet 67P, well, that's because the stuff was going through in that fast flow of water, breaking off the sharp edges, and then it got shot into outer space. And then it got collected. And that's what he predicted, that asteroids would be flying rock piles. Then how do you get water erosion on Mars? Well, some of this water came onto Mars, and it froze. It went into the ground and froze. And then if it gets hit by a comet or a meteor or something, that's going to generate heat. And so it's going to thaw it out, it's going to drain, and make water erosion on Mars where there's no rain. Okay, and then they say, okay, well, if this theory is true, oh, and by the way, I gave this book to the professor. She had it for about 6 months, and then we got back and we talked about it for about an hour and a half. And she said, if the assumption is true, the science works. She just didn't believe the assumption was true. So everything I'm telling you right now is backed up by a geologist, professor. She just won't believe it. But, okay, so if this did happen, would it leave a mark on the Earth or on the moon? And the answer is yes. Yes, it did. it pounded the near side, which is counterintuitive, pounded the near side. See, the earth side, that's got all the red stuff, and then it peppered the far side. Okay. And then let's see. Yeah. These are the predictions that he made. Okay. That he predicted there'd be pooled water under mountains, and that was confirmed. He predicted there'd be deep channels on the Bosporus and Gibraltar. That was confirmed. And then salt on Mars. That was confirmed. He predicted that there'd be rocks on asteroids and comets are rounded. That was confirmed. He also said that asteroids would be flying rock piles, and that was confirmed. And then he predicted there'd be carbon-14 in old bones, and that was confirmed. Okay? And you can see more of this. Basically what I'm doing today is I'm cracking the door to creation open to people. And I hope people kick it down. I'm so excited to talk to the youth at the schools Monday and Tuesday, that they can use this information and spread it. Okay, so are there verses in the Bible that would justify this? Yeah, because when I talked to that person, one of the big objections is, I don't believe there was water under the oceans back then. It's like, well, why not? There's water under the oceans today. They found these deep smokers. These are springs in the sea. If they're coming from the bottom, these are super hot water coming up from the bottom of the oceans. Well, if it's coming from the bottom of the oceans, where is it coming from? Below the oceans. So there is water underneath the oceans today, and it's coming up. And Job wrote about that. He said there's springs in the seas. And we didn't find them until 1977. And also understand that granite, you remember those 5-mile compression, it makes it turn to like putty? There shouldn't be any water underneath granite, because it's not going to be able to drain down there. But what happens? There's going to be no seal. You shouldn't find water underneath 5 miles of granite. And yet Germany and Russia, they drilled holes. Germany's was 5.7 and Russia's was 7.6 miles deep. And what did they find? They found crushed granite and water. I believe it was salt water. And they were just astounded. That shouldn't be there, but that's what it was. So there's a lot of information that points to this. And I think he was just brilliant. Okay, what are some of the lists of answers to the hydroplate theory objections? You can go into rsr.org/answers, where there's going to be people that critique it, and then they're going to answer the objections, which is a blessing. And they even publish it. And that was on Bob Enyart. He was saying, should we put the criticisms of the HPT on here? I said, yeah, put it there. Give people all the information so they can think. Set an example for the government schools, right? Don't you wish you had all the critiques of evolution on their pages? And so they did. They put the criticism of the hydroplate, and then they answer the criticisms. Brian Young does, and Kevin Lee, mainly Brian Young. But yeah, they're just brilliant guys. And let's see. We have a couple of minutes. I'm going to go show you how the Grand Canyon formed. We'll go back up to Grand Canyon real quickly. And Grand Canyon, the key to Grand Canyon is bulging and cracking. Bulging and cracking. So what happened with the Grand Canyon was there was 2 lakes that got formed on that Colorado plateau. And those lakes have tremendous kinetic energy. And so there's a lot of force there, and they're going to come down with tremendous force. Let's see, there we go. And, okay, and I do a talk on this. I should have had it at the end here. But a lot of that force, when one of those lakes breaks, it's going to cut with tremendous force. They call it Grand Lake and Hopi Lake. And this is after the flood, after the rock's gotten hard. And it's going to come out with such tremendous force, it's going to make that canyon there, that funnel-shaped canyon. And once you see it, you can't unsee it. And it keeps cutting down until it hits the Kaibab limestone, and then it spreads out. And so now you got all that sediments that's removed, probably thousands of feet, and it cracks. So the water runs through that crack. That's Marble Canyon. And then it goes down south, and then right where it bends there to the left, there's another lake. That's Hopi Lake. And these are about the size of Great Lakes, tremendous potential energy for that falling rock. And it undercuts that lake, so now that's draining. And it's a waterfall, it's 20 times higher than Niagara Falls with 100 times the flow or something like that, just tremendous water. And so that's cutting across that sediment, and then the Kaibab plateau rises up because there's nothing pushing on, and then that cracks, and then the water cuts through the canyon, the Grand Canyon, and then and then there's that there's the inner gorge, which is hard rock, crystalline rock that splits. It's cutting through the canyon. It reduces more of the weight, and so the mantle itself cracks, and it cuts through that quartzite rock, making the inner gorge. Because when it hit that hard rock, it should have just spread out, but it cracked, and then it goes through the bottom. So that, in a nutshell, and Brian Nickel does a great job with that. If you want more details that point to it, like this rock that's up, and it's about 5,000, 10,000 pounds. Uh-oh, I think I might be getting close to the battery. But, so that's Grand Canyon. Those, again, I've done a talk on that. And, so bulging and cracking. That's how the Grand Canyon was formed. And it all makes sense in my perspective. It's the best thing that I've seen. Okay, so let's go back to the Bible verses that would support something like this. And it's really amazing how Walt Brown put this together. Okay, the Bible verses. And Walt Brown, there's a reason why you haven't heard about this for 40 years. And okay, let's do the Bible verses. They're in the back of your handout too, I believe. This is Psalm 136:6. To him that stretched out the earth above the waters. So there's earth above the waters. And Psalm 75:3, the earth and all the inhabitants thereof are dissolved. I bear up the pillars of it, Selah. So there's pillars holding it up. That's where the granite and the basalt are touching, Psalm 75:3. Psalm 33:6-7, by the word of the Lord were the heavens made, and all the host of them by the breath of his mouth. He gathered the waters of the sea together as a heap. He lays up the depth in storehouses. Lays up the depth in storehouses. Yeah, I suppose for the flood. For he that founded it upon the seas and established it upon the flood, Psalm 24:2. And then this. Does this sound poetic? This is Genesis. They say this is just poetic language. Does this sound poetic or historical? In the 600th year of Noah's life, in the second month, the 17th day of the month, the same day were all the fountains of the great deep broken up, and the windows of heaven were opened. That's historical. Genesis is historical. It's not figurative. And this is, or who shut up the sea with doors as it would break forth, as if it had issued out of the womb, Job 38:8. And also, and the waters stood above the mountains, and at the voice of thy thunder they hasted away. Can you imagine what it sounded like when the mountains were formed? At the voice of thy thunders. Hast thou entered into the springs of the sea? That was in Job 38:16, thousands of years ago, before the scientists found them, the springs in 1977. And Jonah says, I went down to the bottom of the mountains. How would they know there are mountains in the ocean? And so again, there's that controversy, and that's on rsr.org/HPT. Feel free if you want to. Jane Albright did a lot of research on that. But I'll give you these resources again, and then we better fill in the blanks. We'll fill in that blanks. Again, the hydroplate theory. If I go too fast, just let me know. The hydroplate, hey, do you guys want a participation? Who wants to fill these in? Who wants to yell them out? Half of the blank was inside the earth. Half of what kind of the water? Yeah, the ocean. Half of the ocean was inside the earth. Okay, the blank, what gravity pulls on the earth? The moons, that's right. Water gets hotter and hotter, it can't boil because there's no room to expand. Very good. And then in the 600th year of Noah's life, the second month, the 17th day of the month, the same day were all the fountains of the great deep were broken up, and the windows of heaven were opened. Blank, water erupting between two cliffs that are 60 miles high. Oh, boy. Yeah, water, between two cliffs. That would be the sediment. What caused the sediment, I believe. The mid-oceanic ridge rock is removed, so the mantle bulges. Mountains. The mantle rises, and the blanks, and the slide from friction-free until they meet resistance and buckle deformity. And the plates of the continents, the continental plates, the plates of the continents slide friction-free until they meet resistance and plates buckle to form mountains. Plateaus. Mountains sink down into the mantle, and plateaus are raised up. Pacific Ocean, the mid-oceanic ridge rises, so the Pacific Ocean gets sucked down. Submarine canyons. Water gushes off the continents and cuts canyons into the continental shelf to fill the Pacific Ocean. Okay, the Ice Age. Warmer winters and cooler summers, so the snow does not melt. Does anybody? I'll read through them all very fast at the end. Frozen mammoth. Some stuff from the great deep erupted with such great force it left Earth's atmosphere and returned as muddy frozen hail. The blank. Okay, 90th grid. The blank. The Earth. What? The Earth. It rolled. The Earth rolled to bring the Mammothville to Mammoth Hill. Okay, what in granite will spark when compressed? Yeah, quartz. Very good. Oh, chondrules. The plate slammed down when the pressure is released, and Z pinches the rock and gets propelled into. Where does the chondrules get propelled into? Space, yeah. Blank and blank. Big rocks from the great deep get propelled with such force they escape Earth gravities and become dirty snowballs in space. What's a dirty snowball in space? What? Comets. Very good. Comets and asteroids. Okay, moon. Material from the great deep pounded the what? What side of the moon got pounded to make lava flows and moonquakes? The near side of the moon. And the deep hole, 6.7 miles in Russia, found crushed granite. Good. And confirmed predictions. Olivine found in, it's one of those dirty snowballs. Olivine found in comets. Asteroids will be flying piles made of rounded boulders. And then these are the Bible verses on the end. And then again, the best sources of information are hydroplate.org. Oh, yeah. Yeah, there's a brand new website out there, hydroplate.org. And I found my thing. If you want to see when the Hydroplate conference is, take one of these sheets. It is September 21st to the 23rd. I'll be emceeing it. They asked me, it's like, I've never done it before, but if you want me to, I will. And I'll be emceeing it. I'll be giving a talk. I'll be actually introing that. And then also, if you want to see problems with plate tectonics, grab one of these that's full of plate tectonics. And the question is that I like to ask when they're being presented, how did plate tectonics start? How do you get a continental plate to submerge underneath another one? How does that start? And they have a hard time answering that. Again, rsr.org, Real Science Radio. They do tremendous work. If anybody I encourage you to watch that. Search Walt Brown Week and Comets. That's a good source. Kevin Lee, and also Jane Albright. She's the one that does the controversy on why you haven't heard about it. Brian Nickel on YouTube, and also Mike Snavely. He's got missionimperative.com, and hopefully he's recovering well. And with that, I think I will hand it over to Pastor. Thank you very much.
All right, we're going to take our lunch break at this time, and that's scheduled in your little booklet here, 12:15 to about 1:15. That's downstairs. You may make your way down to the fellowship hall through the stairwells in the Welcome Center, and there's some serving lines down there. Some folks will direct you through. And also, again, if you want to register for the next seminar, it's back there at that table. There's a little poster back there. If you have a question you want to submit, a specific question for Brian at the end, towards the end of the third session after lunch, we'll take time for those questions as well. I do ask that you try to keep the questions concise, specific, and directed at some of the topic of discussion today, if at all possible. Okay? I'm going to pray up here so that when you go down, you can just go right ahead and partake of lunch. So let's bow together and ask the blessing. Father, thank you for the time we spent here today. We thank you also for the meal that has been prepared for us, and we ask that you bless it to our needs. In Jesus' name, amen. We are dismissed for your lunch break.